Hello, this is a continuation of section 4.4. Example 4. Solve the following systems of equations. X plus 2y minus 3z equals negative 1, x minus 3y plus z equals 1, 2x minus y minus 2z equals 2. So just like before, I'm going to start off by labeling my equations A, B, and C. Next, I'm going to choose which variable to eliminate. And actually, any one of them would be easy in this case, but since x already matches in two of the equations, I'm going to choose to eliminate the variable x this time. So I'm going to start out with a minus b. So that becomes x plus 2y minus 3z equals negative 1. X minus 3y plus z equals 1. X minus x cancels out. 2y minus negative 3y is 5y. Negative 3z minus z is negative 4z. And negative 1 minus 1 is negative 2. Okay. So now that I did a and b, I have to do a and c or b and c. And it really does not matter. I'm going to do b and c this time. So I want the x's to match. So that means I need to multiply b by negative 2. So I'll do negative 2b, which gives us negative 2x plus 6y minus 2z equals negative 2. And then c, I don't need to multiply by anything. Okay, then I go ahead, add these together. The x's cancel out. We get 5y minus 4z equal to 0. So now these are my two new equations, D and E. The next step is to eliminate another variable. But I'm hoping you realize that both the y and z match, so I'm just going to go D minus E. Five y minus 5y is 0. Negative 4z minus negative 4z is also 0. So we get 0. And then negative 2 minus 0 is negative 2. So we get 0 equals negative 2. Thankfully, just like with two equations and two variables, whenever you get a number equal to a different number, that implies no solution, and we are done. Example 5. Solve the following systems of equations. 3x minus 4z equals 0. 3y plus 2z equals negative 3. 2x plus 3y equals negative 5. So now I need to determine which variable to eliminate. Well, I notice in equations B and C, the y's match up. So those would probably work out quite nicely. So let's go B minus C. Now, I have no x in B, so nothing minus 2x is negative 2x. 3y minus 3y cancels out. 2z minus nothing is negative 2z. Negative 3 minus negative 5 is 2. So there's my first equation. And now this is going to show you a little bit of a deviation from our previous examples, because usually we would pick two more equations and eliminate y from them. But if I just look at equation A already does not have a y in it. So I don't need to do that step of eliminating y because there already is no new y. So I only get one new equation this time, which I'll call D. So now I need to get A and D to eliminate, and it looks like Z would be the easier variable because 2 and 4 have common factors. So I'm going to take negative 2d and a. So that becomes 4x plus 4z equals negative 4. And then 3x minus 4z equals 0. We get 7x equals negative 4. And then, sorry, I do notice a sign error that I just made a few steps ago. This shouldn't be negative 2x minus 2z. It should be negative 2x plus 2z, which means I want to multiply by a positive 2. So then 2 times equation D would become negative 4x plus 4z equals positive 4. And when I add those together, we get negative x equals positive 4. Divide by negative 1, divide by negative 1, we get x equals negative 4. Now I need to plug this either into D or A. I'm going to plug it into D. So we get negative 2 times negative 4 plus 2z equals 2, which is 8 plus 2z equals 2. Subtract 8, subtract 8. 2z equals negative 6. Divide by 2, divide by 2. Z equals negative 3. And now that I have x and z, I need to plug it back into one of the original equations to find y. I'll go ahead and do equation b. So then we would get 3y plus 2 times negative 3 equals negative 3. 3y minus 6 equals negative 3. Add 6, add 6. 3y equals 3. Divide by 3, divide by 3. Y equals 1. So then our answer to the original system of equations is negative 4, 1, negative 3. So this example is really to show you that you don't have to do every single step every single time. Sometimes, depending on what's missing or what you are given, there are shortcuts. And I will save this for a third video on this section.